Hello and welcome to an explanation of the effective temperature on an equilibrium system and thus the equilibrium constant. In order to determine the effective temperature on an equilibrium system, we must consider both Le Chatelier's principle and collision theory. Le Chatelier's principle states that if a constraint is applied to a system in equilibrium, the equilibrium will shift so as to tend to counteract the effect of the constraint. If a temperature change is applied to an equilibrium system, the system is going to shift as so to counteract for that temperature change. Collision theory states that a reaction only occurs when the particles have enough energy to overcome the activation energy. The activation energy plays a massive role in determining whether the reaction is going to favour the forward or reverse reaction when a temperature change occurs. I'll go further into this as we move along. In order to apply Le Chatelier's principle to an equilibrium reaction, we must consider the energy as part of the reaction, as either a reactant or a product. For an exothermic reaction, energy is released into the surroundings and thus is considered a product. As we can see here, the energy has been put onto the product side of the reaction. For an endothermic reaction, energy is absorbed by the surroundings and thus is considered a reactant. As we can see here, the energy has been put onto the reactant side of the equation. First of all, we're going to be looking at an exothermic reaction. With this, an increase in temperature is going to shift the reaction to the left. This is going to remove this excess energy that has been produced and thus increase the amount of reactants in the solution. This can be further explained by looking at the reaction profile. As we can see here, the forward reaction has a much smaller activation energy than a reverse reaction. Now, an increase in temperature is going to assist the particles in overcoming the activation energy. For the forward reaction, this is not going to have much effect as there are so many particles already overcoming that activation energy due to it being so low. However, it is going to affect the reverse reaction as there are not many particles overcoming it in the first place. Therefore, the reaction is going to favour the reverse reaction, shift to the left, and increase the amount of reactants. In terms of the equilibrium constant, we can see the equation is products over reactants. Therefore, an increase in reactants is going to increase the denominator and therefore decrease the equilibrium constant. For an exothermic reaction, decreasing the temperature is going to shift the reaction to the right in order to gain back this energy that has been lost. This is as well then going to increase the amount of products in the solution. If we look at the reaction profile, decreasing the temperature is going to result in less assistance for the particles to overcome the activation energy. Therefore, the reaction is going to favour the side that needs the least assistance. In this case, it's the forward reaction as there is a much smaller activation energy. Therefore, the reaction is going to favour that reaction. So then it's going to shift to the right and increase the amount of products. In terms of the equilibrium constant, an increase in products is going to increase the numerator and thus increase the equilibrium constant. On the other hand, for an endothermic reaction, increasing the temperature is going to shift the reaction to the right. This is going to remove this excess energy that is being produced and thus increase the amount of products. Again, if we look at the reaction profiles, as stated before, an increase in temperature is going to assist particles overcoming the activation energy and favour the side that needs the most assistance. In this case, the forward reaction is the one that has the large activation energy and therefore that is the one that's going to be favoured. This is then again going to result in a shift to the right and increase the number of products. In terms of the equilibrium constant, an increase in products is going to increase the numerator and thus increase the equilibrium constant. For an endothermic reaction, a decrease in temperature is going to shift the reaction to the left. This is going to produce the energy again that has been lost and increase the amount of reactants in the solution. Again, if we look at the reaction profile, decreasing the temperature is going to favour the reaction that needs the least assistance, which is the reverse reaction, as stated before. This is going to shift the reaction to the left, increase the amount of reactants, and if we look at the equilibrium constant equation, an increase in the reactants is going to decrease the equilibrium constant. Thank you.